All right, it looks like it's slowing down, so we'll go ahead and get started. Welcome. This is the webinar for the integration from APIs to Z segments. We will start here in just a second. Please note you are all in listen-only mode. If you have any questions, go ahead and put those in that question box in the bottom of your menu. We'll either get to those as we're going through the presentation or save them for the end. And just to verify, everybody will receive an email following. It usually comes out within about a day or so that gives you a link to both the recording and the slides for the presentation, so you can go back to those and look at those afterwards. All righty. There's your question window. A little bit about eMedApps. We are a healthcare information technology services company providing practices, clinics, and hospitals with a full range of services, as well as a suite of products that are designed to increase efficiency and facilitate communication. We were founded in 1999. We have been working as a partner with NextGen since 2001. We work as a subcontractor for NextGen. We serve healthcare clients all across the USA, and we have services and products specifically for NextGen, as well as products for EHR agnostics. So we do work with other systems as well. And go ahead and follow us on some of our social media platforms. We're out there on Facebook, on Instagram, Twitter, LinkedIn, and we have a YouTube page with many videos out there as well. So just look for eMedApps and subscribe to our YouTube channel. We'd love to have you guys on there. All right, our presenter today is Vic Shashadre. He is our VP of Product Development. He's been with the company since its founding, and he brings his experience and deep knowledge of the healthcare community's toughest challenges to consistently deliver excellence, innovation, and success to clients. And a fact, it's been said that Vic knows all the best quotes from the best movies and TV shows. So I'll pass it on to you, Vic.
Thanks for that, Holly. Okay, so let's talk about integration. So some level setting as we get into this. The purpose of today's webinar, I call it Integration 101. So back to those college course days, a freshman introduction to integration. We're going to talk about some of the concepts and terminology that you'll see when you are discussing healthcare integration. We'll get yourself familiar with the most common types of things that you'll run into when you're talking about healthcare integration, and that way you can recognize and understand what you're dealing with there. And I'm going to break this up into three sections. The first is we'll talk about technology, really looking at this as how systems connect to each other. Is it telephone, email, text? In terms of how you would connect to another person, how does integration work? What are the methods of communication that's leveraged in integration? Once we've defined the methods, the next thing we have to look at are the languages that are spoken. How do these systems talk to each other? How is the data encoded? How is that information transmitted from one system to another? And then finally, we'll wrap it up and kind of look at some of the different integrations that are in practice today. Beyond the standard things that everyone's used to, what are some of the other things that people are doing in healthcare integration to get the juices flowing, get some ideas of things that are out there and things that are probably available to you today from your EHR vendor. So let's jump right in, and we'll start with looking at the technology that's used in integration. Again, what I'm going to be focusing on here are the most common things that you'll see out there when you are looking to integrate with other systems. There's certainly not an exhaustive list in any of the facets that we're going to cover today, but just want to cover those common topics and make sure everyone's familiar with those items. So from a communication methodology, we really see four main avenues of communication when integration occurs in healthcare. The first is via TCP/IP, which are low-level network connections between two systems. File transfer direct messaging, and finally the use of web services and APIs are really the four main methodologies that we see out there in healthcare integration. So let's jump into each one of these and kind of look at them in a little more detail. So TCP/IP is a network-based connection over a socket between a sender and a receiver. So it's a point-to-point connection where a sender sends to an individual receiver. So it's always a push where messages are pushed from a sender that originates them to the receiver that gets them. It is a serialized method of communication, meaning that the messages are sent in sequence. So you send a message, the receiver acknowledges the message, and then the sender moves on to the next message. So if I've got 100 messages in my queue, it's going to send the first message out. It's going to get a response back saying that, hey, I received that message. Then it'll move on to message number 2, and so on and so forth till it flushes through that queue. This is great for communication within an organization. So when I'm connecting my lab system to my EHR or my radiology system to my EHR, all of that sits within my own organization. These are great methodologies used to communicate there. Very efficient from a point-to-point perspective where I've got a single recipient that needs this information and I can send that data through. This becomes less effective when I start to move outside of my organization. The first area of concern, and it's a big one, is security. By definition, the socket is not an encrypted method of communication, although it does support encryption sitting on top of the socket level communication. The problem with that is most systems don't handle that out of the box. So when you're dealing with your EHR vendor and a third party and you want to encrypt the socket traffic, it's not a trivial thing to do. Most systems don't support that, although more and more are nowadays. If you want to leverage the socket and go outside your organization, really the go-to method to do this is to set up VPNs. So you set up a VPN between the sender and the listener, and you then send your data through that socket over that VPN, so it's encrypted as the data travels through. As you can imagine, since it's point-to-point, if I have multiple interfaces with multiple different recipients, now I'm talking about managing and maintaining multiple VPNs so that I can communicate securely with each of those different receivers. This is definitely the most common integration in healthcare. Most interfaces that people set up are going to be TCP/IP socket-based integrations from that sender to the listener, but that is changing. As we're seeing new technology emerge in healthcare, we're seeing different integration systems come into place as well. The second one we talked about was file transfer based. It's pretty much what the name describes. I send a file to someone else for them to consume that file. That could be using some sort of a transfer protocol like FTP. It could be as simple as putting a file in a folder that another system will then pull to pick up and bring that information in. It is, again, a push type of interface where a file is generated and then that file is consumed. This is really better suited for interfaces that don't have to be real time, because the file is placed in a location and someone picks that file up. This is really a batch type interface, right? So you're scheduling to say, I'm going to pick up from that location every 10 minutes, every 5 minutes, every 30 minutes, whatever makes sense based on the data that's being transmitted. You can achieve near real-time operation if you crank up your polling frequency. So if I say, you know what, I'm not going to look for these files every 5 minutes, I'm going to look for these files every 15 seconds or every 10 seconds. If I do that, then I can get to almost a real-time set up with this interface, so that as those files are getting created, I'm grabbing those files and I'm processing them and bringing that data into my system. It lends itself nicely for secure communication outside of your organization. The SFTP and the FTPS transfer protocols build security into them so that I can securely transfer these messages, or these files, I should say, across my organizational boundaries. Those same file protocols have the capacity to ensure delivery of the message, so that when I'm doing a get through, say, SFTP, that get ensures that the file is successfully transmitted before it moves on. So I'm not going to get a case where I get a partial file and think that it's a complete file. With these file transfer interfaces, those files could contain multiple messages. It doesn't have to be a single message at a time like our TCP/IP setup was concerned. I could have multiple messages in that file and process those. However, those are generally processed sequentially from the file. So most systems will navigate that file from top down and process those messages sequentially that are in there. Direct messaging. This really took off in the last few years with some of the meaningful use requirements around transfer of care. Really fueled the adoption of direct messaging. Direct messaging is a very simple method of sending information from a top level. It is basically email. So it's built on top of the email protocol, which is SMTP. The direct protocol defines the security envelope that goes around that message to ensure that it's secure and available only to that recipient. There is a little more of a burden to entry with direct in terms of getting set up and being able to leverage direct. Generally requires a third-party service provider. These are called HISPs, or Health Information Service Providers. They manage the direct addresses in their organization. They manage the security protocol. They provide the certificates that are required to properly encrypt messaging. Most EHR vendors are their own HISPs, so they're providing direct messaging as part of that EHR in different capacities depending on the EHR vendor that you're dealing with. These different HISPs are linked together using the direct trust network that allows for lookup of addresses across the different HISPs, as well as delivery of messages across the different HISPs. So this gives you the ability to send messages to recipients regardless of the HISP that they're connected to. So this is seen every day in practice when you're sending a direct message from your EMR system to a recipient that's running a different EMR system. What's happening in the background is that message is getting transferred from your HISP to their HISP and then being delivered accordingly from their end. So it does create a nationwide network of recipients that are available to you. Because it's email based, that same connection can deliver to multiple different people. You just address the message to whoever it needs to go to based on their direct address, which is in essence an email address that you're sending that information to. The last protocol we're going to talk about here are web services, or APIs as they're commonly referred to. You may see that that nomenclature around a lot of places. API stands for Application Programming Interface. I didn't put it into my talk here. I probably should have done that. But what web services are they're basically ways to connect systems over the internet. They are designed at their heart to be distributed, which means they're open and available to many different consumers. So it's not a point-to-point like our TCP/IP, but can support traffic from multiple different organizations at the same time. So multiple systems can connect in and push and pull information. As a result of this, it's a highly scalable integration technique. So if I'm trying to connect to hundreds of different entities, web services are a great solution for that. In web services, security is built into the connection protocol itself. All of the connectivity is through secure web protocol, so similar to what you would use while you log into your banking website or something like that. The traffic is secure and it's built right into the protocol, so it's not something you have to think about in addition when you deploy a web services-based integration. They're starting to gain a lot of popularity in healthcare. Web services have been around for a long time. They're leveraged in a lot of industries to a great extent. Mobile applications leverage web services for predominantly everything that they do. But now we're starting to see web services gain popularity and starting to see a lot of traction in healthcare as well. You know, in the generic sense, a web service can support what we call Crud operations, which are basically create, read, update, and delete. So you can push information by creating something new. You can fetch information by reading. You can update information, and you can delete information. Now, depending on how this integration is deployed, you may or may not have all of those operations available to you, especially when you're talking about APIs and how they're deployed and delivered by EHR vendors. They limit the functionality that you can do with them. Okay, let's move on. Now that we've talked about how these systems connect to each other, let's talk about the languages that are used when they speak to each other. So I establish a connection, whether it's TCP/IP or it's a file-based, or I'm using web services, or maybe it's a direct message. What is the language that I'm speaking? What is the data that I'm, how is the data encoded, I should say, that I'm communicating with each other? So these are, again, some of the predominant languages that are used in healthcare integration. The first is Hl7 2.x, as I call it. It's basically a version of Hl7 integration, very common in healthcare, and we'll talk about that in more detail here in a second. Hl7 3.0, NCPDP, Uscdi and Fire, as well as IHE are languages that you should be familiar with, as they're being used in healthcare integrations day in and day out. So let's start with Hl7 2.x. The most commonly used language in healthcare for integration. It's been around for a long time. Most of your common integrations, like your lab orders interface and things like that, are going to be Hl7 2.x integrations. There are many versions of Hl7 2.x, ranging from 2.1 to 2.9, although some are definitely more popular than others in healthcare. 2.3 is used a lot in healthcare. 2.5.1 is used a lot because of some of the stipulations and requirements for meaningful use that were in there. But you will see integrations that use other versions as well, depending on both the source and the recipient in terms of what they support. They're basically evolutions of each other. As Hl7 released new versions, they added potentially message types, different things that you could put into the message, and created a new version out of it. All of them function very similarly in how the messages look when you see them visually. All of these Hl7 2.x messages comprise of different segments that carry data in separate fields within that segment. And the segments are defined by the Hl7 standard that you're using. So for example, if you're using Hl7 2.3, that defines a set of segments that are available to you and a set of fields that are available to you in those segments to contain the data that you're interested in sending. In Hl7 2.x, messages are broken out by message type, and they define a series of message types that are available to you. What I've got here are what I would consider to be the most common message types in healthcare integration. They're certainly not exhaustive again. And as you go to different versions, there are different message types that are available to you in those versions. But these are terms that you will often see when you're talking about healthcare integration, when your organization is going through a project to implement an interface between two systems. These are the kinds of terms that you're going to see. So I just want to kind of make you aware of them. ADT are demographic messages, SIU or scheduling messages, so appointments, creations, cancellations, those kinds of things. DFT or financial messages. The most common one you're going to see here are charge messages that you're sending. So if I'm sending a charge message from my EHR to my practice management system, if they're not integrated, they're going to be done over these DFT messages. ORMs and ORUs are orders and results. ORMs are orders, ORUs are results. They could be any type of order or result. It could be a laboratory order, it could be a diagnostic order, and the associated result with that. RDEs are medication orders. So if I am sending a medication order over Hl7 2.x, that's going to be through an RDE message. VXUs are immunizations. So as you're reporting immunizations to your state registry or your local registry, you're going to be using VXU messages to do that. And then finally, MDM messages are transcriptions or notes. So if I'm receiving Hl7 2.x discharge summaries from my hospital, for example, they're potentially going to be MDM messages that are coming in there. In terms of the segments that make up these message types, there are hundreds of different segments that are available in your Hl7 specification, again, depending on which version of Hl7 that you're in. These segments are specific to the data that they're carrying. So for example, the PID segment is your patient demographic information, and it carries patient demographics. Multiple different types of demographics are carried in that segment, like the medical record number, their name, address, phone numbers, things like that, ethnicity, and so on and so forth. PV1, for example, is a patient visit. So this is going to contain information like the visit location, the rendering provider on the visit, the date of the visit, the class of the visit number, for example, are going to be in that PV1 segment. RXA is a pharmacy administration segment. This is going to be things like medication orders, the drug, the dose, the SIG for that medication are going to be in RXA. So this is just an example of three segments that you're going to see often in healthcare. There are a ton more as you're dealing with different message types that are being transmitted. Another one that you might see that I wanted to bring to your attention are Z segments. Z segments are custom data. They're not part of the specification from Hl7. So if you have a interface in your organization that has Hl7 2.x messages and you open one up and you see these Z segments in there, that's what they are. They're custom segments. They're not defined in the specification. They're defined based on either the sender or the receiver or both in terms of that particular integration that you're doing. All of the Z segments begin with the letter Z. So if you see something that starts with a Z, it's a custom segment in there. So it allows you to do additional information in your message that may not be part of the Hl7 specification. You'll often run into cases where vendors will insert data into an Hl7 message that's a little bit off-label, if you will. So the field is defined for a certain type of information, but they put something else in there. That's very common. And then you'll also see organizations that create these Z segments as well to deal with custom information. So let's take a look at an Hl7 message. So for those of you that have seen Hl7 messages this before, this should look familiar. Wanted to kind of go through it so you get an idea of how to interpret these messages when you see them. All Hl7 messages, or I should say a majority of Hl7 messages, will start with an MSH segment. This is your message header that basically gives you information about the message that you're looking at. I've highlighted a few fields here and to give you some information about them. The first is MSHs will always start with a character definition. These are encoding characters that are used within the message. So these tell you how fields are separated, how subfields are separated, how subfields are separated, and how control characters are escaped within your message. You'll also see the message type here. This will tell you what kind of a message it is. So I see ADT. That tells me this is a demographic, an admit or discharge message for the patient. And then the AO3 tells me what type of message it is. So an AO3 is a discharge message. So I know from looking at this that this is a discharge of a patient in the system. Like we talked about earlier, PIDs are patient information segments. So here's my demographics on that patient. I've got the name highlighted here. I've got medical record number, date of birth, things like that in here as well. So once you know the segment, what the meaning of the segment is, what the field layout is, you can gather a lot of data just by looking at this Hl7 message. Although initially it looks like Greek, as you kind of dig into it, it makes a lot of sense in terms of the data that's laid out there. Hl7 3.0 was the evolution of 2.0. People love 2.x so much that it really wasn't adopted very heavily in terms of live interfaces. It is a XML-based standard, whereas the 2.x standard that we just looked at is a flat file that contains information. Hl7 is XML-based. And XML is a markup language, I should say, that uses elements and attributes in a hierarchical structure to represent data. So I've got a very simple example here of an XML fragment to define a phone number, for example. So I've got this parent element called phone. Underneath that parent element, I've got two child elements of area code and number, as well as an attribute of type that defines an attribute to the phone elements. So I know that this is a home phone number, and I know the area code is 847 and the number itself is 4906869. It's a very simplistic representation of an XML, but again, once you understand how the data is encoded, you can start to read the XML messages and make sense of it. By far, the most commonly used 3.0 message in healthcare is the CCD, or the continuity of care document. It's used in transitions of care when you're sending patients. That direct messaging often carries these CCD messages, although it's transferred different ways too, depending on the deployment and the use case. So here's a example of a CCD message. What I've done is I've broken it out based on the elements in the message, so it's kind of a little easier to see. But it follows that same hierarchical structure that we talked about with that simple phone message. We've got parent elements and we've got child elements that sit underneath it. And so, for example, here I've got highlighted in here a patient child element. This is the element that contains the patient information. So if you're looking at a CCD and you want to find out who the CCD was for, you can dig down into the element structure. If you open that CCD in something like Microsoft Edge or Internet Explorer, it'll automatically create these nodes for you, but there are other tools that do it as well. And you can dig down into that node structure and you can find that patient node, and underneath that patient node are all the demographic information for that patient. So you can identify who's the patient that's associated with this message. Similarly, you'll see these component elements at the towards the end of the message, and this is all the clinical data that's part of that CCD. So you have repeated component elements for each clinical data type. So for things like immunizations, results, medications, allergies, and so on and so forth, each one is going to be its own component data, and you're going to be able to look into that and see the details there. One of the nice things the CCD schema does for you is it defines a human readable version of the data. So all of the data that's in the CCD is stored in two locations. It's in the human readable location and it's in the machine readable location. And the reason they did that is in the human readable section, it basically has text descriptions of everything. So you can quickly look at it and make sense of the data that's there. In the machine readable section, it has code information on that. And we'll talk about that a little bit more here during this webinar. But that way, when a system processes that CCD, it's able to interpret that data and understand the particular medication that was prescribed for that patient. NCPDP is the National Council for Prescription Drug Programs, and they're responsible for maintaining standards around prescription drugs. The most common standard that they have is the NCPDP script, and this is used by all the EHR vendors to send e-prescriptions, especially those that use SureScripts to route those e-prescriptions. It is the standard that SureScripts uses. So if you're using SureScripts to route your e-prescriptions from your EHR to your pharmacy, this is what you're using on the back end. It's NCPDP script. It is an XML-based standard, similar to the CCD, for transmitting that prescription information. So while you may not see this XML from a front-end perspective, when you go into your medication module and you send this script to the local Walgreens, for example, this XML is getting generated on the back end and is being routed. So if you ever need to troubleshoot and you ever need to look at how this is happening, this XML will contain the information for you. So this is what the NCPDP script looks like. Again, it is an XML-based messaging standard. So what I've done here is I've created that element hierarchy so you can look at what that looks like. All of the data that's in that script is encoded in that hierarchy. So you'll see here you have a new RX element, and then underneath that new RX element sits all of the information about that prescription. The first thing is the pharmacy. Where am I prescribing this to? It contains the identification number for that pharmacy that SureScripts uses to route that message to the appropriate pharmacy. It contains the name of that pharmacy. So if I'm reading that XML file, I can tell where this script was intended to go to. It contains a patient element that has information on the patient. So it's got demographic information on that patient. So you could tell who the script was generated for. And then finally, it's got a medication prescribed element that contains information on the actual med that was prescribed. The coding for that med, the description of that drug, quantity, refills, the SIG, things like that are all encoded in this medication prescribed element. So if I wanted to dig into an XML script for that patient, this is sort of your key to understanding that script and being able to find the information that's in there. The next one I wanted to talk about was Uscdi and Fire, and I've kind of lumped these together because, again, based on requirements that have come out, these are being used together by EHR vendors to satisfy those requirements. Uscdi is the United States Core Data for Interoperability. That's what the abbreviation stands for. And what it does is it defines a core set of data and data elements that belong to each of those data groups that need to be exchanged for interoperability. So in order to be Uscdi compliant, when you share, for example, a procedure, Uscdi dictates what are the data elements about that procedure that need to be shared. So that in order to be compliant with that, you need to share all of those data elements. It's sort of the minimum data set, if you will, to share when exchanging information, clinical information between systems. This was required by the 21st Century Cures Act, I should say, in terms of EHR vendors being able to support this. So when your EHR vendor talks about their version of EHR being compatible with the Cures Act, this is what they're supporting. They're supporting among other things. They're supporting USCDI for data exchange. USCDI defines these different data groups for exchange of information. So assessment and plan of treatment, care team members, clinical notes, goals, health concerns, immunizations, laboratory, medications, patient demographics, problems, procedures, provenance, smoking status, device information or device identifiers, and vital signs are covered in the USCDI. And then underneath each of those are a series of data elements that are required to be supported from that given data set. Fire is being used by a lot of EHR vendors to achieve that USCDI compliance. Fire stands for Fast Healthcare Interoperability Resources. It is how they're exchanging this data set between different vendors. Fire defines different resources that can be pushed or pulled from systems. Fire is based on web services. So web services are the underlying communication mechanism within Fire. So it's a little bit unique on the languages that we've talked about because it prescribes both the language and the communication together in how that integration occurs. Like I said, a lot of EHR vendors are using Fire as their methodology for implementing compliance with USCDI. Fire, by definition, supports both an XML-based approach, like we've seen with the CCDs and the NCPDP format. However, Fire does also support JSON, and that's a term that I haven't talked about yet, so I wanted to spend a couple of seconds talking about JSON because that's something you're going to see if your organization is doing a lot of web services or API-based integrations. JSON stands for JavaScript Object Notation, and it's basically a way of communicating data made up of key value pairs. So it's a value type and then the value itself. So on the right-hand side here, I've got a snippet of a JSON element that basically transmits codes that are being used. So again, it's a key value pair. So in this sense, I've got a key value called coding. The value of that is an array in this sense, so I'm passing multiple codes in there. And each of those array elements is a combination of a couple of key value pairs, the coding system and the code value. And then there's the actual data available to me here. So again, when you look at a JSON transmission or a JSON file, it may look very cryptic, but when you start to read it, it'll make a lot more sense as you look for these key value pairs, and they fall under that same hierarchical organization as you would expect that you see with XML in being able to move that information across. So further with Fire, most EHRs are using Fire as part of their API offering. A lot of the EHR vendors are using Fire as their patient-facing API. What we see with a lot of EHR vendors, they're enterprise APIs, so that the APIs that go beyond just the patient-facing information tends to integrate Fire with proprietary calls that they've defined. So it uses a combination of both. Some are proprietary only. Most use a combination of both in terms of their enterprise API. Like I said earlier, there are a number of different resources. I couldn't list them all in this presentation. So what I've got here is a link to the Fire resource online that will list out all of the different resources that are available based on the different versions of Fire that are available as well. So definitely click into there when you get the presentation, and you can certainly look into those details as well. IHE, integrating the healthcare enterprise, is what it stands for. is a little bit different in its inclusion in the language section. It's not a language per se. What IHE does is they define a series of what they call profiles across clinical domains, so that when systems say that they're integrating based on a specific IHE profile, it defines exactly how that integration occurs. It defines the communication method, it defines the languages of how those two systems are going to be talking with respect to each other. It's used very commonly for clinical document exchange, and that's why I've included it in here. Whether that's HIEs that use it or peer-to-peer clinical document exchange, often leverage IHE profiles to be able to do that. These are the different IHE domains that are supported with the IHE profiles. The one that's of interest are the patient care coordination, where they define these document profiles for exchanging documents between sender and receiver. And we'll talk about that a little bit more when we talk about healthcare integration in practice. So those are common languages that are used in healthcare integration. One thing I wanted to talk about in the language discussion is the vocabulary that's being used. So you can think of this almost like a dialect of that language, so that when I'm speaking that language, I'm using a certain vocabulary within that language so that my receiving system understands what I'm sending. And this is what's used to codify information in the messages, so that the receiving system is able to interpret that message that came across and understand exactly what that data elements refers to. So again, some common terminology that you'll see in terms of coding in healthcare integration. The first, SNOMED CT, is the systemized nomenclature of medicine clinical terms. This is a pretty encompassing set of clinical terms that can get codified. It could apply to things like patient problems. It could apply to other areas as well. CPT, current procedural terminology, are procedure codes. So procedures that occur on patients will get encoded using CPT. ICD-10 is what's being used now. The International Classification of Diseases. These are for problem coding. So patient problem lists, things like that, can get coded using ICD-10. LOINC, the logical observation identifiers, names and codes, are used to codify observations. So lab results, even some diagnostic testing, you're going to find LOINC codes for. NDC, National Drug Code, is used to encode drug information. So when I'm prescribing a drug and I'm sending that NCPDP XML message, that drug is often encoded using NDC, which is then interpreted by that pharmacy so they dispense the correct medication for that patient. And Metaspan is also a drug encoding system that's used by some very popular EHR vendors. So I wanted to make sure I include this in there. You'll often see this term, and in fact, in some of the EHR vendors' case, you'll see a Metaspan database as part of your EHR implementation. So if you're ever wondered what that's for, it's the drug encoding that's being used when you prescribe medications within the system. So we've talked about the technology, how these systems connect to each other. We've talked about the languages and the vocabulary that's being used when they talk to each other. I wanted to wrap up the webinar with spending just a couple of minutes talking about how that's being used today and things that are available for you and things you can leverage in terms of integrations within your organizations. The first is we're seeing a lot of integration now with non-clinical systems. So things that you wouldn't have thought about initially of integrating with your clinical side, bringing that into place. So things like your CRM or ERP systems, your telecommunication systems. So your phone system can integrate with your EHR and your clinical systems as well. using the same methodologies that we've talked about here. So as healthcare has gone to sort of some of these more commonly accepted web services-based integrations, people are leveraging that to integrate other systems in as well into their environment. Fire APIs are starting to be more popular. Patient-facing applications, as those Fire patient-facing APIs have been mandated on these EHR systems, we're starting to see more and more applications that are leveraging them available for patients to consume. Smart on Fire is a term that you might hear, and I wanted to throw that in here real quick and kind of describe what that is. Smart on Fire is really used for clinical decision support. And what that allows is for clinical decision support modules to be plugged into your EHR so that they integrate right into your EHR when your EHR has Smart on Fire support. And it allows, based on actions that are occurring within that patient's chart, for one of these clinical decision support resources is to be used, and information to be brought back and presented to the clinician within the EHR of information that might be pertinent to them when they're making these clinical decisions. So it's really powerful, starting to gain more popularity. It's been around for a few years. When Fire first came out, Smart on Fire followed. But as Fire has started to gain popularity, Smart on Fire is starting to gain popularity as well. Enterprise APIs, so leveraging your EHR vendor's API so that you can do things within your organization that you previously didn't think were possible. So you can go in and grab data out of the your EHR for data analytics, whatever your own products that you're creating to be able to leverage that as well. Care Quality and Commonwealth are networks that are available for peer-to-peer data exchange. Really powerful to be able to pull information in from your peers for data they may have on that patient that you're seeing within your organization. There are different vendors that participate in these two different protocols. The real reason we have Epic that does Care Quality and Cerner that does Commonwealth, and then other EHR vendors often do both or one or the other that's part of there. So your EHR vendor probably takes part in one or both of these. When you participate in Care Quality or Commonwealth, your data is being shared as well. So organizations can search for information in your environment and pull that data out based on consent rules and based on the state that you're in. That could be an opt-in or an opt-out that happens there. They're using the IHE profiles to do that. The IHE profiles we talked about in languages is what these guys are using to exchange that document back and forth. And finally, HIEs that may be available in your community where they're aggregating data and making it available to providers. They could be providing that data on demand. So you send a query to your HIE that says, hey, I want information on patient John Smith. That HIE might be aggregating on demand. So when they get that query, they're reaching out to their constituent organizations and saying, hey, give me all the data that you have on John Smith, and then they're aggregating that out and pushing that information over to you. Or it could be a continuous push of information. We have HIEs that are doing push notifications. So when a patient is seen in the ER, the HIE pushes out a notification to clinicians associated with that patient to say, hey, your patient was just seen in the ER, and spurs a follow through from the clinic side as well. So a lot of different fun things that are starting to happen in healthcare as we're starting to leverage more and more technology in the integration space. So that's Integration 101. I wanted to open the floor up to any questions that might be out there.
Okay, I do have a couple. So first of all, is file transfer using an SFTP and FTPS secure?
It is, yeah. Both SFTP and FTPS have a secure component associated with it. There is a certificate that has to be used as part of that exchange, so you can SFTP across your organization boundaries, and it'd be a completely secure approach to doing it.
Okay. Next question. Do web
Holly,
services...
real quick. FTP is not secure. So you don't want to do FTP across domains in terms of exchanging information. Sorry, go ahead.
Okay. No worries. Okay. Do web services take a toll on the system performance?
Great question. It depends on how they're deployed by your EHR vendor, or if you're doing your own web services, how they're deployed. Most EHR vendors deploy their APIs at a centralized location, and communication is occurring internally between the centralized API and your particular instance of your EHR, if it is a local instance of the EHR. So that mechanism is usually well designed not to put a great deal of load on the on your system. The APIs themselves are designed that way. So APIs aren't used for data transfer, for example. So I can't go out and say, hey, send me all the patients that you have in your system, or send me all the appointments that you have scheduled in your system. The API will limit the amount of data that you can fetch from the system, particularly for this purpose, because they don't want the production to get affected as data is being grabbed from your environment.
Okay, thank you. Another question, how do you find an HISP?
So the first place I would look is your EHR vendor. Most EHR vendors are also their own HISPs. They're providing direct email information for their users. If they're not their own HISP, they will point you in the direction of HISPs that their users have worked with for enabling direct. Because remember, direct was required, I should say, for certification under meaningful use. So vendors came up with solutions for this, whether they did it themselves or they partnered with another HISP to provide those services. They have something in place for dealing with this. So go through your EHR vendor and they can point you in the right direction. If you're not an EHR and you're looking to integrate with a HISP to be able to receive direct messages, then Direct Trust is a great source to go to find more information.
Okay, thank you. All right, and another question, what protocols, formats, or methods do you see being the standard going forward? Will one type win out over all the others?
Another good question. I don't see Hl7 going away anytime soon, the 2.x, I should say. It is just so widespread in terms of its usage in healthcare. So that's definitely going to stay. And I think APIs are going to be a large portion of integration as well. The percentage of integration that's going to be done via API is going to be increasing over time. So I think at the end of the day, we're probably going to see, I don't know if it's going to be 50-50, but we're going to see a lot of Hl7 2.x type integration and API-based integration. Now, things like CCDs fall into the API umbrella as well. The exchange of the data may be via an API, but it could be a CCD that's being sent in that API call. Fire definitely supports an API call for fetching a CCD on a patient. So it's basically your way of getting clinical data on a patient is to grab a CCD on that patient.
Gotcha. Thank you. And one last question. It looks like we are almost at time, but with all of this, why do I still have to tell them my insurance meds and all of that info every time I check in for an appointment?
That's a great question. I guess the best way for me to answer that question is inertia. You know, we're seeing movement in the industry towards more collaborative, integrated systems. I think we're going to see improvement in that, and hopefully, at some point, that those kind of requests will be a thing of the past. But right now, they're here.
Hope so, hope so. All righty, any other questions? I think that's all I've got. Okay, well, thank you. Thank you, Vic.
Thank you.
If anybody has any follow-up questions, again, you will receive a copy with a link to the recording as well as the pages. If you have any questions, feel free to reach out to us on our website if you know your individual rep, or you can send an email to info@emedapps.com. We thank you for all of your time and hope you guys got some great information today. Have a good afternoon.
Thanks, everyone.